Okay, so part B asks us to describe the experimental procedure you'd use to make the additional measurements needed to determine IB. Include how you use your measurements to obtain IB and how you'd minimize experimental error. So here's one example of valid procedure that they give in the answer key. I consider this one, it's a pretty simple one, and I think it's a good one to use. So they have us just to displace the bar by a small angle and then release it to oscillate. So here you can just say theta. And the point of that is you want to measure the time it takes for it to go from here, the point at which you released it, and then over here, and then back. That's going to be one period. And they want us to do that 10 times. And the reason 10 and not just one is it asks us to how we'd minimize experimental error. So the more trials you do, and the more trials you do and then take the average of that, the less likely it is for there to be error. You want to reduce errors. That's why there's 10 complete oscillations. You could have done 20 or 30. It doesn't matter. As long as it's like more than one, I guess. So you can have 10 complete oscillations. So once you have a value for all those 10 periods, you can divide by 10 to determine the average value of the period. And then once you have that, we have this equation here from the last part. If you just go back for a second, right? This equation. Period is equal to 2 pi times the square root of IB over mgx. We can use that equation. We found the average period. You can just plug that into here. 2 pi is just a constant. We have m, we have x. Those are given values. G is a constant. So we can use all of that to solve for IB. And then that's how we can determine IB. And this is the experimental procedure. There are other ways to do it, but this is one way. Part C says, now suppose you're not given the location of the center of mass of the bar. So determine an experimental procedure that you could use to determine it, including the equipment that you'd need. So here's one way to figure out the center of mass. Typically, these kind of problems, finding the center of mass, it's kind of like a balancing thing. You balance the bar, balance the object. That's because when you're, like in this case, when you're balancing the bar here at the top of this fulcrum, say we have it right here, and this is the center of mass, okay? That's what this orange dot is. So if you're balancing it on the fulcrum, the bar is going to naturally tend to lean like this because it's heavier on this side, so gravity is going to pull more on this side. And it's heavier on this side because the center of mass is there, right? So it's going to pull on more on this side. It's going to lean this way. So basically what this experimental procedure is saying is that you want to like experiment with it. If it's leaning to the side, you want to move this overall bar to the left to make sure it balances out until you get to this point where it's completely balanced out. And the fulcrum is going to be at the center of mass, because basically what the center of mass is that all the mass is here, and then the rest of this stuff over here and over here, that's going to be equal. So gravity is going to be equally pulling on both sides, right? That's when this is going to be completely balanced, right? So when it's horizontal, balanced horizontally. And then that's what this needs. And then all the equipment that you need, you just need the bar, you need the fulcrum, and that's it. So yeah. So that's the end of the video. Thank you for watching.